So, you have a video game that you think would make a pretty great randomizer, do ya? No? Well, you at least got a game you want to play in Archipelago, but no one's made it yet? Alright, well, you've come to a place. As the developer of 2 AP worlds that some people even play sometimes, I figure it's about time to document my process for posterity's sake, and so that Vi can spend even more time correcting my awful decisions. That's where you come in. This is the first video in a series that we're going to create a whole Archipelago implementation from start to finish and actually release it at the end. But before I go into what the series is, I think it's important to first establish what it is not. First, this is not a programming tutorial. I am not teaching how to do basic control flow, or how classes and inheritance work, or how to use an IDE. If you're confident enough in your programming skills that you could hear, oh, mods for this game are all written in Poob, and you have a decent idea of how you could get started coding in Poob, you're probably ready. It's not impossible for you to make an AP world as your first major coding project, but maybe hit up a different video series going over some coding basics first and then come back to this one. Just make sure that you leave the tab running in the background, it's good for the algorithm. Second, this is not a one-size-fits-all method. For one, every game's modding situation is different. You could be digging through bytecode and messing with memory stacks. You could be following a well-trodden path for the game with a massive modding scene, or you could be recompiling the game from source with your changes already in place. But even on the AP world end of this, there's as many different ways to write an AP world as there are AP worlds. What I'll be showing you is my way of doing things, and a lot of that is from a perspective of someone who doesn't really like Python all that much. I'm gonna screw stuff up, implement things poorly, or give some probably bad advice. Stick around with the whole series because there will probably be a follow-up video where I go over all of the stuff that more experienced developers tell me that I got wrong. Third, this is not an eternal guide. Despite all of its major features and general robustitude, Archipelago isn't even 1.0 yet at the time of recording. Things are going to change and break probably within a few weeks of this video going up, but the concepts should remain mostly set. So if you're following the guide and something just straight up is not working the way it is for me, check to make sure that it's not obsolete. It might not be you, it might actually be me. With that all out of the way, let's get into it. In case the B-roll in the background or the soundtrack haven't given it away, this series is going to be going through an implementation of Command & Conquer Red Alert, specifically using the OpenRA engine, which is a re-implementation of the first 3 Westwood Studios RTS games. To keep the scope reasonable, and it's because it's the one that I grew up playing on PlayStation, we're sticking to just Red Alert for now. The first step you need to do before developing your randomizer is to play your game. You've probably played it a lot, but now you're going to do it with an eye towards making an AP world. Before you boot it up, it's a good idea to know what you're looking for, so let's go over the structure of an Archipelago implementation first. Most complete Archipelago integrations come with 3 parts. The AP world that defines the logic and generation. This is written in Python and will be part of the main Archipelago ecosystem. This part will be decently similar for all games. The game mod, which handles actually doling out the items and detecting when you've done a check. This is going to be very specific to the game you're implementing, and is likely the thing that a tutorial like this will help the least with. But I'm at least going to try to give you some pointers for where you can find that information. And finally, the client, which serves as the go-between for the other 2. The client communicates with the hosted Archipelago server and tells it when you've done a check, and notifies the game mod when it receives an item. This one is a little special because depending on the game, it can belong to either side. Some games use a generic client like SNI or BizHawk that's already included in Archipelago, while others have the client wrapped up into the game mod itself, so you'd enter the server info directly into the game. Still others have a separate program that you run alongside the game to handle the communication. This part is the most free-form. All it needs is the ability to access WebSockets and communicate with the game process. Then it could be coded in literally anything you want it to be. This is the order that we're going to be tackling them in this video series. First, we're going to be making an AP world in complete isolation, under the assumption that the other two parts will just work the way that we expect them to. You can essentially think of them as large black box with code goes here for now. That's a problem for future you. For now, let's focus on the AP world structure. An AP world is going to define some number of items that you can unlock, and an equal number of locations to find them in. The simplest way to handle this is to just take all of the items that were in those locations and shuffle them, but games like Stardew Valley, StarCraft, and old school RuneScape show that you don't need to be quite as literal with what counts as an item. While the rest of this series is going to continue using the terms item and location, because that's what they're called in the code base, if it helps, you can think of them more as unlocks and tasks. First, let's talk about items. Since items are the things that give you access to new locations, it only makes sense to start here. Items can come in 4 categories: filler, useful, progression, and trap. Progression items are any item that gives you access to a location. Even if that item gives you access to exactly one new location, even if it only sometimes does, if that item can give you access to new locations, it must be marked as progression. On the other end of the spectrum, traps are items that are bad to collect. Things that actively hinder your progress, like freezing the character in place, dealing damage, giving you some sort of cursed item that comes with a major downside, or being forced to watch cutscenes in Sonic Adventure. Many games don't have these at all, and most of the games that do have them as opt-in challenges that only appear when you have enabled specific settings to include them. The last 2 categories, useful and filler, both define items that are at least not detrimental to pick up, but don't directly give you access to new areas. The only functional difference between them is that if a player sets in their options to exclude a location because they don't want to be forced to do it to get a progression item, a useful item also cannot be placed there, while a filler item can. As such, the general rule of thumb you should use is, if I want to guarantee that any player will at some point have this item, it should be useful. If an item can be totally ignored, it should be filler. Next up, locations. It is worth noting that it's the responsibility of the locations to know which items are necessary to reach it, rather than the item knowing which location it unlocks. This makes locations more complicated than items, since they're where the logic lives. On the surface, locations may seem easier, since all you really need is just a name and ID. There's no location type I need to spend a paragraph explaining, but the logic rules get really tricky and will almost always be the thing that trips you up the most. Here's where a strong understanding of Boolean logic is going to come into play. You would need to construct rules like can be accessed with the gravity suit and either grapple beam or ice beam, things that cover all possible angles. In order to make things a bit simpler, locations can belong to a region, which is basically a collection of locations that have a shared access rule. As an example, all objectives in a specific mission in Red Alert are only going to be accessible if you've unlocked that mission. So making a region for each mission with the requirement of having that mission unlock item means that you don't need to include that item in the logic for every individual objective. Regions are stupid powerful if you can think of them more as collections of rules rather than actual regions in space. RuneScape, for example, uses regions for nearly everything. The ability to train a skill, access to a spinning wheel, monster drop tables, they're all coded as regions. With all that new knowledge, it's time to boot up your game for a thorough dissection. I recommend making a Google Docs spreadsheet to keep track of things as you go. I usually make separate tabs for items, locations, and regions, along with a notes tab for miscellaneous things that come up, like settings ideas or potential soft blocks to be aware of. For now, play through your game, and anything that looks like it would make a good location or item, put them in the list. You can pare it down later so the numbers match up. Here, I'm playing through all of the campaign missions and noting down each primary and secondary objective as locations, with items being the mission unlocks themselves. After that, I'll add in the units and structures and a few nice perks like more starting ore, or bonus power from power plants, or faster building. I'm also keeping an eye out for shared access rules that can be used as regions. Grouping missions by their unlock as described above is good, but making groups for no-build missions, low-tech missions, and high-tech missions lets me group rules based on how many units and structures you have unlocked. Note that I do not yet know what those values mean. This step should be fairly loose. You can settle on actual numbers through testing later. The point of making this a spreadsheet instead of going straight into code is that things are malleable. You can easily cut things, adjust logic, or add new things as necessary much easier in a document than in code. Once you're done, you should be left with a list of items with their classification, a list of locations with some rudimentary access logic, and a list of regions and what rules they might have to reach them. This is all that's needed to make your AP world a reality. And next episode, we're going to get started with the code end of things. So get yourself a Git client and a Python IDE. We're diving into the deep end next time. And before you go, here's a little bit of life advice. There will come a point in this whole process where you'll start questioning whether this is even going to be any fun and if it's worth pursuing, in which case I would like to remind you that old school RuneScape is core verified, so that literally shouldn't even be a concern for you. Good night, everybody.
We'll make ourselves known.
Soon we will stand. Soon we will stand. Soon